phase response. Now how to draw this functions is very important to understand. So what you can do is you can make one table where take the values of omega. In the first column we will find out corresponding values of mod of h of omega, and mod of h of omega is 1 by 3 into 2 cos omega plus 1. And in the second column we may find out the value of phi of omega. Now there is nothing much to find about phi of omega. It is either 0 or pi, which will depend upon whether this mod of h of omega, that means 1 by 3 2 cos omega plus 1, is positive or negative. But please note that when you find mod of h of omega, we will have to take mod around this particular function also, because here we are only plotting the magnitude part. So what are the values of omega that you will go for? You will take some few values of omega so that you can draw the plots properly. Let's say, for example, omega is equal to 0. One can take pi by 8, pi by 4, let's say 3 pi by 8, pi by 2. Then I will just take that midpoint 2 pi by 3 because this is the value of omega which differentiates between a phase being equal to 0 and pi. After 2 pi by 3 I can go for values like, let's say, 3 pi by 4, and finally let's say pi, for example. One can take more values also. So all you have to do is find out the values of mod h of omega, put it in the first column, find out the values of phase phi of omega, put it in the second column. So this will be the values. Once you use the calculator in a function mode and put the various values of omega in this predefined function, you will get all these values. So you can see that up to 2 pi by 3 the values of magnitude response start from 1 and keep on reducing. All these values are positive, and hence phi of omega will remain 0 in all these cases. And then you can see the values of mod h of omega start becoming negative. Obviously we will not take negative values in the magnitude response. The reason that it is magnitude response, it will only have positive values because there are mod signs. But these negative values tell us that phi of omega will be taken as pi, which is also very obvious because once you cross omega equal to 2 pi by 3, the values of phi of omega will be plus pi. And now I'll quickly make this both value as positive because we have taken mod signs here. And with that, all you have to do is finally plot both magnitude and phase response. Ideally we should plot them from minus pi to plus pi, but we will only plot them for 0 to pi because the other side will be something you can easily make out. We'll see that how. So you can see once I plot mod h of omega, at omega equal to 0 the value will start from 1, and this is my pi somewhere at 2 pi by 3. So this is our pi by 2 point where the value will be 0.33, and somewhere at 2 pi by 3 the magnitude response will fall down to 0, and then it will again increase, and at omega equal to pi it will be equal to 0.333 again. So this is how the magnitude response will look like. On the other side, if I had to draw it, it will be exactly same because it's an Eon function. So this is how the magnitude response will look like for the given system. This will be nothing but minus pi by 2, and this point at which the function is becoming 0 is 2 pi by 3 and minus 2 pi by 3. How will the phase angle look like? Up to 2 pi by 3 the phase value will be 0, so I'll just put a 0 line here, and then the phase value will increase, will take a jump to pi. So all we have to do is take a jump to pi. So this particular value will be nothing but plus pi, and it starts from 0. Now suppose if you had to draw phi of omega completely for minus pi to plus pi, then you have to remember that phase is nothing but an odd function. So odd function will have the symmetry in the opposite quadrant. So the value for 0 to minus pi, it will be 0 in some portion and then it will become minus pi. So this is 2 pi by 3 point, and this is minus 2 pi by 3 point, where the shift in phase will take place from 0 to pi and minus pi. So that's the final answer where we had to draw the magnitude response and phase response. So the final conclusion is, given any question, you have to somehow obtain h of omega first. From h of omega, you have to find its magnitude response mod h of omega, its phase response phi of omega, which can be done by taking magnitude and phase of any complex number that we do. Make this table, take few values of omega, plot magnitude response and phase response. Magnitude response will be always even, phase response will be odd. Plot them as per the values which you get. And how to get h of omega? So there are various ways. You might be given h of n first. In that case, find h of z. You can convert h of z to h of omega. Sometimes h of z will be given directly, so you can find out h of omega again. You might be given the difference equation, like was the case in this question itself. Again, you can find h of z, and from there you can find h of omega by putting z equal to e raised to j omega.